Okay, let's give you guys some more practice. So use trigonometric substitution to integrate this. So press pause and have a go. Okay, so to integrate this, you should complete the square on this because if you look at a right angle triangle, let's say this is A, X, and B, then this length here will be the square root of x squared plus b squared by using Pythagoras, and this length here will be square root of a squared minus x squared. So you see you want to complete the square because you want to get this in the form of one of these here. So well, complete this. If you look at this, you've got x squared here. You've got x squared here. So get it in the form of something squared. So complete the square on this. So use whichever method you want. The method that from our section on completing the square, we've done this before. Use whichever method you want. For me, I would factor out the negative. So use whichever method you want. Hang on. So it would be this, and then minus 3. So let's just concentrate on this bit here. So rewrite this whole thing here as this, and then now complete the square. Completing the square would be us needing always us needing half of this thing here. So completing the square would give us this. Always going to need half of this. Half of that is 1 here. So it's going to be squared, and then minus the rubbish straight away, and then you carry this down. So if you don't understand this, use whichever method you want. So that will then give you this, and then tidy this up. It will then give you this. Hang on, x plus 1 squared minus 4, and then now incorporate the negative. So that will then give you 4 minus bracket x plus 1 squared. So this whole thing here is this thing here. Use whichever method you want. Somehow get it in this form here. So completing the square on this will then take us to this. Okay. So now it's just a matter of integrating this. But before we can integrate this, our eyes should zoom into this bit here, and then we need to create a right angle in such a way that this is true. So we need to create a triangle in such a way that this is true. Well, if you make this to be 2, and then if you make this to be x plus 1, then the adjacent here has no choice but to be square root of 4 minus x plus 1 squared. So this length, the adjacent here has no choice but to be this. So let's just call this angle here theta. So to integrate this, you will need to create your triangle like this. So once you've got your triangle, so hang on. So we were trying to integrate this. To integrate this, your eyes should zoom into this bit here, and then create a triangle in such a way that this is true. Well, once you've got your triangle, if you look at this here is sine theta. So sine theta equals opposite over hypotenuse. So opposite over hypotenuse, and then from this times both sides by 2, and then well from this make x a subject. That will then give you this. Differentiate it. It will then give you dx equals this thing here. And then so that's one part done. Now the second part. Now we need to look at the second part. Well, the second part would be us looking at this thing here. This here is cos. So cos the angle equals the adjacent over the hypotenuse. So cos the angle would be the adjacent over the hypotenuse. And then tidy this up, times both sides by 2, that will then give you this. So now if you look at this here, the complicated bit here, including the square root, is this bit here. So we can now put this into this whole thing here. We can the dx part, we can put this into the dx. We can put this into the dx, and then the x we can put this into the into the x here. Then this whole thing here will then become this. Will then become this. So now these two will cancel out, giving you this. And now it's just a matter of integrating this, which is quite straightforward. If you integrate this with respect to theta, it will then give you this. But then now we don't want, so this is our answer, but we don't want the answer in terms of theta. We want it in terms of x. So if you look back, once you're here, if you look back, we said that let sine theta be this thing, and then we also said let cos theta be this thing here. So once you get to this stage, hang on. Once you get to this stage here, look back. Earlier we said let sine theta be this and let cos theta be this. So once you get to this stage here, look back, and then now we can see that cos theta. So we can put this whole block into here, and sine theta. Well, you can inverse this, or you can inverse this, but select this. This is simpler. So from here, theta would be inverse sine of x plus 1 over 2. Okay, so we can put this into here, and then put this block into this cos here. Then this whole thing here will then become this. So this is your final answer. Okay.